Everyone. Today with us we have Mr. Satish Jedwani, Director and Training Head at EZ Engineers Private Limited. He is a registered Buddha Structural Engineering and Structural Engineer and QPMP Level D qualified by the Certified Project Management, Switzerland. He has almost 18 years of experience in structure design of power plants, material handling, as well as oil and gas structures. He has worked in different countries like Germany and Saudi Arabia. On behalf of Civil Engineering Department, Barrow University, I welcome Sir to deliver a lecture on softwares in civil engineering. Welcome, sir.
Thank you. Good morning, everybody. Thanks for giving me this opportunity. Uh, should I start directly?
Yes, sir. You are on Facebook Live. You should start very.
Okay. Thank you. Okay, friends. Uh, now, softwares. Like there are so many kind of softwares which we are using in our field. Okay. Let's see few of the softwares which can be helping you in your future to build your career. Okay. I will share my screen. Okay. Friends, yes, few of the softwares which you may already be knowing, like Autocad, okay, then Sped Pro, then you may have already few other common softwares which you may have heard already, Revit, maybe Tekla, and Excel, of course, which we are using for the manual calculations. Okay, friends, whatever calculation we do in Excel, in the professional life we use the word manual only. Means if you prepare the calculation by Excel, that is manual calculation only. And the digital calculation means when you are using the analysis and design softwares like StatePro, okay, Save, ETAPS, okay. So friends, these are the few of the softwares which you will be using in your future. So let's see what work actually it does and how we can make our career in one of this or more of this. Okay, of course it is not necessary to learn all the softwares, it depends on your interest. Okay, let's see. AutoCAD. So first of all I will show you a drawing. I think you can see this drawing, and this drawing is made in AutoCAD. Okay, friends, this same work can also be done in MicroStation. So all these softwares, AutoCAD, MicroStation, even this software, JWCAD, okay, all these are drafting softwares. Okay, friends. So let's see this. Okay. So friends, these are the drafting softwares, and next to this, these are friends analysis and design softwares. Okay. Okay, friends. So these are the analysis. I will open few of these softwares and I will show you that how we use this. Okay, and this is Revit, or Tekla. Those are animation 3D softwares. Okay, I'm not talking about the moving animation, or rather, you can write physical modeling. Okay, friends. So these softwares, which these softwares are analysis, these are also 3D softwares. Okay, but these are analysis and design softwares, whereas these are physical modeling softwares. I will show you what is that. Okay, now let's see. Okay, hold on.
Using advanced software methods, the Putty Writer may.
Okay, friends. The screen now which I am sharing, at your screen you can see a model. This is a 3D physical modeling. Hold on, friends. This is a physical modeling. This is showing you the connection details. This is from Tekla. Okay, these are means the Tekla will be making this kind of model. This is used for fabrication detailing. So this is not the analytical and design software. Now I will show you analytical and design software. Hold on. See, friends, how will we will be using these softwares in our project? Let's see. Friends, first of all, when you are working in a civil engineering firm, how your work will be started? This drawing will be at the last stage. Okay, this is the final drawing which will be releasing, you will be releasing from your office. First of all, you will be getting this kind of drawing. Okay, this is the input drawing. Okay, this is the input drawing. This drawing is not prepared by civil engineers. This drawing is prepared by mechanical engineers. This drawing is prepared by piping department, equipment department, layout department. They will be deciding how the layout will be there. This is the plan of an industrial building. And if it is a commercial building, then it will be something like this. I will show you. See, friends, this is a plan of a commercial building, like a mall. Okay, there are shops and all those things. Okay, the this is the cross section of that drawing, that particular building. You can see your basement. You can see some roof shape is given. Okay, So this drawing is again not prepared by us. This is prepared by friends, architectures. Okay. So this is input to us. Now based on this input, now I will open the State Pro. Hold on. Hold on. Okay. Okay. It's a heavy software. It will take some time to open. Okay, friends. So this is the state model. So based on this drawings, you will be preparing state model. Okay. Now you have opened this. You will be preparing state model here, friends. You will be defining the member sizes. You will be giving different loads like this. Okay, this is the analytical and design software, and see the difference. This is the physical 3D modeling. So in the starting, first stage is you get this drawing. Second stage, based on this, you will be modeling this. After doing this, again, of course, this learning of this software is not easy. Learning of AutoCAD, learning of Revit, learning of Tekla, that can be done even by a diploma person also. But for learning of this, for State Pro, you must know structure engineering. If you don't have good concepts in steel structures or RCC structures, if you have not learned structure engineering concepts, then friends, there is no meaning of learning State Pro. In State Pro, you can model the bracings, columns, beams. Here also you can see the rendered 3D view like this. You can see like this. But friends, for modeling this, you must have knowledge how to decide the column orientation, where to put the bracing, whether to put bracings here or cross bracing, V bracing. If you don't if you don't have that knowledge, then there is no meaning of learning state, because how you will model the bracing if you don't know the location of the bracing? Because modeling is quite easy. You can just take the command and you can just model some like this. That's all. Okay. So it's easy to model, but it's hard to understand. So friends, we need to learn whenever you are planning for these softwares, State Pro or SAFE or ETAPS. Okay. You can learn any of this. No need to learn all of this. Any of this. But along with that, you need to learn the conceptual knowledge. You need to learn how the connection type will be decided. You need to learn first how the column orientation will be decided. You need to learn how the concepts of supports will be decided. Then only we can go with this software. Okay. So once you are done with this software, then you will be preparing the sketches like this. Based on this, based on results of this, you will be deciding the member sizes. See, like here, you will be preparing rough sketches, like say here F means ISS 6565. So you have prepared the sketches like this. This is like a doctor's prescription. Okay. So being a structure engineer, you will prepare this rough sketches, and this sketches you will be giving to a draftsman. Okay. So this softwares, drafting softwares will be used by draftsmen. That means who have done generally diploma or ITI. Okay. Then here, when you are working here, so for this your education should be BE or ME. Not necessarily ME, huh, friends? BE person can easily work on that. I am working on this for last 20 years. I have not done masters. Okay, but it doesn't mean that we need not to do masters. If you do the masters, then of course your value, your market value, your salary, your career will be guided accordingly. And again, for physical modeling of 3D softwares, you again need this knowledge. Okay. So coming back to this, first we get this input. If it is industrial structure, for commercial structure, you will get the input from architect. Based on this, you have done the state modeling. After state modeling, you have prepared sketches like this. Okay. And based on these sketches, the draftsman will prepare drawings like this. Okay. And if it is a steel drawing, then I will show you how it will look like. Okay, this will be the steel drawing. Now, based on this steel drawings, friends, we need to prepare the fabrication drawing. You can understand, see, based on this, the site fabrication cannot be done. This is the only single line drawing. You can see for beam there is a single line. Here it is written MC means moment connection. But what will be the detail of MC? It is not shown here. Okay. And none of the software in this world can decide that whether it will be MC or shear connection, means moment connection or shear connection. That will again be decided by you only. Okay. I will also explain you what is moment connection and what is shear connection. Wait. Okay. But before that, we will just finish first this procedure. Okay. So for this type of steel structure, we need to first prepare again fabrication drawing before sending it to site, and it will be, friends, something like this. Okay, see, this is the detail of that one beam. You can see in this drawing it is shown only one line, but friends, here it is shown like this beam, this cutting. You can see so many dimensions. Even for each angle and each plate, you need to show all such dimensions. Okay, this is called detailed drawing or fabrication drawing. So here in this, what we do, we prepare detailed drawings or fabrication drawings. Okay, so this tekla, and here okay, in tekla we will be preparing detailed drawings, okay, or fabrication drawing. Okay, so This market value of this software is also very high because it's a monopoly software, means very few learn this, and that's why they get good salary, because there is high demand of Tekla software in the industrial field. Okay, but if it is a RCC drawing like this, so we need not to prepare fabrication drawing, then we will be preparing bar bending schedules. Okay, I will show you the bar bending schedules, how it will look like. It's opening, wait for a minute. See friends, okay, this is the bar bending schedule, which where detail of each and every rebar, each and every single rebar is shown. Okay, so after this, construction can be started. Okay, in this we missed this, right? I did not show you what is the purpose of Revit. This is at the initial phase, means when you want to show to the client that how your structure will look like. Okay, so this is the Revit. Even you can make this kind of, even you can make this kind of animations in, I will show you the
The supply
animation
to
of,
each plot, power supply network,
even I will show you the animation of an industrial park. Okay, so for this you can use the softwares like 3D Max, Civil 3D, but again those are all animation software and that can be easily learned by a diploma or ITI person. For that, the proper technical knowledge of B is not required. But the problem is, friends, more than 90% of B civil engineers are working in off field. I mean to say, they could have done a better career. They could have better career, but they could not do that because the lack of knowledge sometimes, of course not all the times, sometimes we don't get the opportunity, but many of the times due to lack of knowledge they cannot enter in a better career in a better field, because say for example entering in this field you must have the knowledge of your structure engineering subjects, what you have done in your college, and also you must have conceptual knowledge. I will now give you the example of conceptual knowledge by explaining what is shear connection and what is moment connection. Hold on, I will share a video. I will share a video of about 10 minutes, then you can have, and if you have any query then also we can discuss in between after just this video. Hold on. A beam. Yes, friends. Which is this beam and which is this beam? Type A and type B. Okay, can you tell me what is this? Friends,
Yes,
have a look on this video for 10 minutes. Friends, focus on the detailing part and listen it carefully.
Yes, you are right. This is simply supported beam, and this one, yes, fixed beam. Now, this we have learned in our academic, in our bachelor's and in our diplomas. Okay. Now, how this beam will get deflected when a load is applied at the center? For example, this, when we apply the load, the deflection will be something like this, and in this case, the deflection will be like this. Now, my question is, have you ever tried this, or you have just read from the book that for simply supported the deflection will be like this, and for fixed beam the deflection will be like this? Have you ever tried? See, understand, friends, all the times we don't need big laboratories and expensive material to try all these things. We can do this simple thing with even a small scale. Would you like to see how? Let's see. Make all some you please. See, here now we are applying load on this scale. Okay, can you apply with the finger, please? See, friends, this is a deflection curve over surface. Now, let's see for a fixed beam. Yes, slightly more. See, can you see the shape? Okay, let's make this shape more clear with the soft one. Okay, now please, this is simply supported, and now this one is fixed. See, can you see this shape? Exactly like this. Thank you. Now after looking at this shape, now can you tell me the picture what I am going to show you? Which beam is that? Whether it is a simply supported or fixed beam? Please have a look on this. Okay, friends. Now, yeah, tell me. Everybody, please. Yes. Can anybody tell me? Okay. Confusion? Whether it's a simply supported or fixed? See. Now, this is the problem. This we have covered in our academic. But the picture which I showed you, this is not covered in academic. This practical thing now, I will explain you, friends. This is column, this is beam. Okay. Now, when this beam is getting deflected, for example, I draw the double line of this. This goes something like this. And in this case, this goes like this. Everybody, clear? So, let's see. Focus on this face. What happens? In simply supported, these beams get, this face gets rotated. There is some theta. Whereas in the fixed one, this is not getting rotated, the theta is 0. Okay? Now how can we achieve this? Let's see. For example, this is an I section beam, friends, and I am holding it from here. Okay? And let's see whether it gets rotated. Yes, of course, it is getting rotated. I mean, this face gets rotated like this. Okay, say instead of 1 bolt, I provide 2 bolts. Okay? Yes, still gets rotated. Slightly lesser, but still gets rotated. Now, quite less, but still this face gets rotated. Okay? Now, how can we make it fix? Let's do some magic. Okay, see the magic. It's not rotated now. It's not rotated. What we did? Yes, anybody? Simple thing. When we hold from the center, it gets rotated. But when we hold from top and bottom, it's not rotated. That is the simple logic. Now, if I see any connection, my dear friends, in this, if I provide a cleat angle with bolts in between. Okay, this can rotate because there is some space here. right? Now, many of the engineers think like that when we are providing weld, it is fixed. No, it has nothing to do with it. Even if you weld it here, this is simply supported only. See, whether we bolt or provide weld, it doesn't have any difference on simply supported or fixed. But where you are providing weld, where you are providing bolt, it has to take concern with this. Understand? If I provide bolt or weld, this beam can rotate. But if I provide a beam like this and say there is no space for rotation here, can you see this space, friend? Okay, I will see. I am talking about this space. I am talking about this. If there is a space, this can rotate. So that will be simply supported. But if there is no space or the space is filled with weld, okay, one option no space, another option you fill that space with the weld, or third option you provide the plates. In all these three cases, the connection will become fixed. Clear about this, friends? Now, if you see any connection, you just need to have a look whether the space is there or not. If there is no space, it's simply supported. If there is a space, then it is fixed. Let's have again a look on this structure, on the beam which we show. Yes, can you see the space there at top and bottom? Yes. So now, which is this connection, everybody? Yes, you are right. It is simply supported. Now let's see one more picture. Yes, can you see this? We can clearly see the weld is provided near the flanges. So there is no space at top and bottom. That means this connection is fixed connection. Everybody clear about this? Though there is a space near the web, but there is no space near the flanges. That's why this connection is fixed. Now you see any connection, whether at railway station, in bridges, in sheds, factories, and you can quickly identify which is this connection. Am I right, dear friends? Okay. Now, which this connection simply supported, actually in industrial language, we call this simply supported as shear connection. Okay, and this one we call moment connection because this can transfer moment also, whether this transfers shear only. And understand, friends, this moment connection also transfers shear, but this connection transfers shear. Hello, friends. Now we have seen the connection types. Okay. Now you can easily identify the connection type by merely looking at it. Okay. Now similarly, let us understand how we can identify the support, whether it is pinned or it is fixed. Let's have a look. Say this is a steel column. These are the flanges. Okay. This is base plate, and below it, of course, it's a RCC pedestal. Okay. Now, here we will discuss about two types, pinned as well as fixed. Now, similar to shear connection and moment connection, if we hold this column from center, this will behave like pinned. And if we hold it from ends, it will be fixed. So, let us say this can get rotate like this. So friends, when I put anchor bolts like this, so of course this plate cannot rotate like this and it will be fixed. That means if I draw plan of this, then plan will be something like this. This is fixed column. Okay. Now, can anybody tell me, if I want to make this column pinned, what should I do? Yes, anybody? Okay. If I remove the anchor bolts, then this column will fall down. Of course, we don't want to get it fall down. We want to make this column pinned. So what can we do? See, this is a base plate and this is a column. This column is welded with base plate and this assembly comes at the side along with this line. Okay, this full assembly comes at the side. And now I put this on the pedestal and then anchor bolts are put on the pedestal. So by putting these anchor bolts in between means like this. Say this is a column, okay? Then we are putting anchor bolts in between. So this will be now pin support. Understand, friends? By putting this here, we allow just few rotation. We are allowing just fraction of radians. Okay, we don't want to make it seesaw. So, if you see the anchor bolts are inside, it will be called pin. And if the anchor bolts are outside, it will be like a fix. I will explain you with a model. See, dear friends, this is a base plate. This is column. Okay, can you see this? That means this is pin support. And this one is, my dear friends, fixed support. Okay, dear friends. So I guess now you know which is pinned and which is fixed. Now it's not merely on paper only. Now you literally know and you can identify easily when, for example, you are taking some selfie and in selfie you can see some support. So even in selfie also you are able to identify, isn't it?
Okay, friends. I think now you have seen that how we do this practically. So first we went through all the softwares, that how we actually work in the project. And friends, there are so many, different positions and different engineers, draftsmen, lead engineer. They all will be working in this in different companies. Of course, a single person, a single engineer is not going to do all these steps. I will show you how actually we work in a company. I will show you the example of my company. Let's see. Okay, I will just carry this laptop to my company so that you can have a better idea. Just to give you a live picture. Okay, you can see all these people are working. Okay, friends, there are different departments in all companies. Okay, how we work in a project using different softwares. Okay, there will be a project manager. Okay, who will be looking after all the disciplines: civil, mechanical, electrical, something like this. See, like this. Above all, there will be friends. Project manager. Okay. Below these friends, there will be different project leads. Okay. There may be say 10 leads. Okay. Project lead for say mechanical, then project lead for civil. Okay. Likewise, there will be different project lists from different disciplines. Okay. Below that, friends, below each discipline, in each department, then say for taking the example of civil, then there will be senior engineers, and senior draftsman. Okay, many companies use word designer instead of draftsman. Okay, so below senior engineers, again, like this here. Okay, so this project manager is above all. Okay, then there will be different these disciplines, like taking example of this project lead civil, say I give different color. Then again there will be senior engineers and senior draftsmen. Okay, now these senior engineers will be working with a team of freshers and junior engineers. Okay, or even trainees. So when you will be starting your career, friends, you will be working here in this segment. Okay, I'm giving you this practical knowledge so that when you will be starting your career, you should have knowledge that what I will be doing. Similarly, if you have done diploma or ITI, then you will be here freshers, means junior draftsman, or you can say trainees also. Okay, so for here diploma or ITI. Okay, friends. Okay. So friends, and here BE or ME. Okay. Now, so this is a different segment. Let's say, okay. Okay, and this is a different segment. Now here what we will be done, say for example in my project there are 10 structures. Okay. So for 10 structures, what we will do, we will assign say 3 to 4 senior engineers and 10 trainees, say for example. So each trainee will be given one structure and he will be guided by a senior engineer. Okay. So, but when you will be able to work as a training, when you pass interview, right? Now, how to prepare for this interview? Of course, I'm not going to show you that video, but friends, you can visit YouTube. Okay, hold on. Friends, you can visit my channel EZ Engineers Private Limited. Not necessarily my channel. You can look on other channels also. Okay, and here you have a video of, hold on. Here friends, you have video for, okay, list of topics for structure engineer interview. This one, okay, interview preparation. So here it is defined how to, for which topics you need to revise, on which topics you need to prepare for the structure engineering. Okay, and other videos which I have shown you are also available here. You can visit when you are free. Okay, coming back to this. Okay, so for being a trainee, you need to pass the interview. Okay, and then you will become a trainee, and you will be working on a structure where you will be guided by a senior engineer. Okay, you need to interact with mechanical engineers, you need to interact with electrical engineers, other discipline engineers, so that you can get the input. If you have any problem in the input, you can talk to them. Okay, and you will also be getting the individual equipment drawings from different discipline. Even friends, you need to also talk with the geotechnical persons. Okay, I will show you a sample geotechnical report also. You can see, friends, you can see a sample geotechnical report from which you will be getting SBC and other other parameters from the for soil, like SBC, coefficient of friction, coefficient of active and passive earth pressures, okay, water level. Okay, so you need to know all these kind of things so that you can become a good structure engineer. Okay. Yes, friends. Now you can ask me the questions if you want. You are free to ask the questions. If you want to ask the questions, you can ask me even regarding the career guidance also. Whatever knowledge I have, I will be happy to help you. Okay. And if you don't have questions, then I can proceed. I would wait for a minute for your questions. Okay, friends, let's proceed further. Okay. That plate. Hold on. I'm going to show you a connection demonstration. Hold on. Wait. Okay, one of you have asked me the question that the difference between BIM engineer and structure engineer. Good question. See, friends, BIM, it's a building integrated modeling. Now, what do you mean by BIM? Yes, I will show you a site rather. Can you see a construction site here? Right? See, there is a work going on. See, can you see? Okay, there is a work going on here. Now, friends, in past, how the work was done? I will show you a video. Hold on. For okay, friends, we are discussing what is BIM and then what is the difference between BIM engineer and structure engineer. Let's see.
the world around us, from stadiums to schools, ports to power plants, and high rises to hospitals. The global construction.
This is explaining you that most of the developed countries have more work in steel structure than RCC structures.
Community embraces the benefits that structural steel offers. As steel is bought and sold for prices dictated by market factors, steel fabricators must continue.
Now this is showing you in fabrication yard how they were working before BIM.
Explore new methods of automation to differentiate themselves against.
See how they do the cutting, how they do handling,
more importantly, increase their profitability.
how they do welding. Friends, this one is the fabrication drawing. So by looking here, they are fabricating.
Past, welded connections could
How they take measurements.
only be designated with manual measurement or semi-dedicated processes of layout marking.
They are marking the dimensions.
Mid-sized to large fabricators have struggled as skilled labor continues to disappear and little technology.
See, he has done cross, means this is need to be deleted, means this is need to be cut. This side portion is need to be cut.
Has been developed to elevate the headaches caused by yesterday's labor.
But now what they do after BIM, say Tekla is a part of BIM. So what they do here, they have created a 3D model.
The Petty Writer maintains an arsenal of programming tools which are second to none. Parts can be easily exported from modern BIM programs into an intermediary file standard.
Now suppose you want to fabricate a column. So you can select a column from that 3D model and you can create this file.
Such as DSTV.
This file is called NC1 file. NC1 file. Now this file
imported into Pettinghouse software.
You will check that whether this is as per requirement or not, and then
see layout markings.
And then you will cut the member. You will put this file in this machine. This machine is CNC machine. Which is this machine? CNC machine. Okay.
System for mid-sized to large structural fabricators.
And this will be done automatically.
And reduce labor costs. The Petty Writer CNC layout marking system is the high-capacity solution for layout.
Weld marking, even the beam numbers.
Marking of structural shapes, such as beam,
will be done automatically. So, this is the magic of BIM. Accurate, less chances of mistake, okay, fast work. Okay. Now, friends, what do you mean by BIM? That means, okay, friends, BIM meaning is automate most of the things and connect most of the things. That means a person working on StatePro, a person working on Tekla, working on the Excel output, all this will be clubbed at one place. I will show you how it will be, something like that. I will show you a photo of a structure of a refinery which is already done with BIM. Hold on. See friends, this is a virtual photograph. Okay, This is not erected, this is not constructed, but 3D model of this is ready. I will show you now a detail of one structure from this. See, this is also BIM. Now say I have just cut one structure from the BIM model. It is showing you structure, it is showing you piping, it is showing you equipments, it is showing you everything. That means, friends, there are lots and lots software which are the part of BIM. If you learn State Pro, it is part of BIM. If you learn Tekla, it is part of BIM. If you learn NCs, piping softwares, KDMS, SP3, these are all part of BIM. BIM means it's a platform. It's not a software, friends. Okay, BIM is a platform where now most of the softwares, whatever this 3D analysis or physical 3D modeling softwares are nowadays developed, they are compatible with BIM, so that you can put your output in that particular BIM platform. So everybody, mechanical engineer, civil engineering, construction person, all will be putting their input to BIM modeling, so that you can do scheduling, you can have quantities, you can have design, all together, all interference with the BIM modeling. So BIM engineer can be a structure engineer, a draftsman can be BIM engineer, a civil draftsman, mechanical draftsman, architect person who is working on Revit, or even a person who is working on a estimation part. They all can be a BIM engineer if their software is compatible with BIM. But the specific BIM engineer means he can he can interfere with this softwares, means he can put all those software in that platform. That platforms are like, I will write down the names of the platform because it may be new for you. So generally when you are working on the softwares, the 3D physical softwares, okay, SP3D or PDMS, KDMS, okay, PDS. These softwares are giving you a full platform, okay, where even the framework plus this is for the modeling part, okay. So friends, when you know these softwares, okay, these are the platforms where you can insert the model from Revit, you can insert the model from framework, you can insert the model from Tekla, you can insert the model from State Pro, ETAPS, every. So these are the actual BIM platforms. Okay. Yes, Jay, I think your idea is clear. Your idea is clear now. Okay. Any other question, friends? If you want to write in the chat, like one of the engineer has written, you can ask me other questions also. Okay. I will just show you a demonstration of a connection plate. Friends, we have seen the connection of a simply supported shear connection, right? It will be something like that. This is I section column and I section beam, okay? And now say if this is connected like this, okay? So friend, this is a shear connection, but when you put connection plate like this, okay, so this is your slotted connection, which you actually show in the drawing like a roller. So roller connection can also be there, but okay, something like this. So which can move like this in axial direction. So this will be the slotted connection. I'm showing you some of these practical things so that you can have more and more interest in civil engineering. Okay. Yes, friends. If you are done with your questions, I will wait for a minute. And if you are done with, then we can stop the session. Friends, we have many courses in structure engineering. Okay. If you want to learn more about such concepts, we offer professional trainings, so many trainings, including softwares, and few of the trainings are monopoly trainings, means we have an international training center in Vadodara. The center name is EZ Engineers Private Limited. EZ Engineers Private Limited, and where we get the students from all over the India, even from out of India. So many engineers, students, professors, okay, even the company managers come here to learn different professional trainings related to structure engineering. And the demo session you have already shown. So there are so many courses. Uh, if you wish more details on this, then you can just WhatsApp us on this numbers which I am showing. Okay. You can ask for the details. You can just message EZ on any of this number, or you can call us for further detailing related to such courses. And there is uh, we are highest in the job placement from structure engineering point of view. Okay, there are so many job placements from our company. That's all from my side. Madam, now you can take over.
Thank you, sir. Thank you, sir, for sharing your knowledge. I think some of the students have joined from the Facebook Live. That's why questions are not visible. But if
No
somebody
issue.
contacts me, I will
No issue.
surely contact you, sir. Thank
No
you, sir.
issue. Thank you.